All right, so we have our power rule for logarithms. Okay, so for all positive real numbers, and instead of m and n, we're going to have m and p. And we know that b doesn't equal 1. So log base b, and if we have some m to the power of p, that p can actually be brought down to the front. So whenever you have an exponent, you can just bring it right down to the front. So it's no longer an exponent, it's just being multiplied to that term. Okay, so for example, if you have log base 5 of 36, you could rewrite that as log base 5 of 6 squared. And just bring that 2 down to the front. So that'll be 2 times log base 5 of 6. Okay. You can't really simplify that anymore because 5 to the power of y equals 6. There's no real number, well, no simple number that can do that. Okay, so let's say, for example, we have log of square root of 10. And we wanted to simplify that. Okay, so we could always do the base 10, but without using the common logarithm. We have log of 10 to the 1/2 power. Just converting that to a 1/2 power. Okay, so if we bring that down, we have 1/2 log of base 10. Okay, now there we actually do know that log base 10 of 10 equals y. 10 to the power of y equals 10 will give us y equals 1. Okay, so this ends up being 1/2 times 1, which is just 1/2. Okay, so that reduced all the way out of being a log function. Just became a regular fraction. All right, any questions on that one? All right. Let's say if we want to simplify log base b of x squared, not plus, thinking ahead a little bit, y to the third z. Okay, so we know already just from the product property that log base b of, let's say, x, y, and z in this case, is going to equal log base b of x plus log base b of y plus log base b of z. Okay, so for this problem, log base b of x squared, why do I keep putting the plus there? Jumping ahead. Y to the third z is going to equal log base b of x squared plus log base b of y to the third plus log base b of z. Okay, so all we did was get all three factors and applied our property. Okay, so now, just the ones with the exponents, we can get those exponents and bring them out to the front. Okay, so that becomes 2 times log base b of x plus, bring that exponent down to the front, 3 times log base b of y. And there's no exponent there, so we can just leave that as it is. Log base b of z. All right. So any questions on that second one? Well, third one. All right. View that up for a few. We'll do one more example of that one. Hope anyone's still writing. Looks like everyone's done. Okay, so let's say, for example, you wanted to simplify, say, log of y to the third times the, let me write that, give that a little bit of space because that's times the fourth root. Times the fourth root of x divided by z. Well, instead of simplify, it probably should have been expand, but since we're actually expanding it. And let me kind of clean up that one a little bit. Looks a little bit messy. I'm trying not to get that 4 and that 3 mixed up. Okay, so for this one, you have a quotient. So the first thing you're going to do is apply the quotient rule. Okay, so that just becomes log of y to the third, fourth root of x, minus log of z. Okay, so doing that, this one's okay. This one, now you still have a product to deal with. So for this one, use the product rule. Okay, which gives us, remember you add those when you have the product rule. So you have log of y to the third plus log of the fourth root of x minus log of z. Okay, so we applied the quotient rule, we applied the product rule, and now we still have to apply the power rule. Okay, and here we're going to apply the power rule because we're going to rewrite it as log of y to the third plus log of x to the 1/4 power. Clean up that g a little bit. Minus log of z. Okay, so now we just bring our exponent down to the front. So 3 times log of y plus 1/4 log of x minus log of z. Okay, so there are some where you only need to do one of the properties, some where you may have to do 2, and some where you may have to do all 3. All right, so bring that down some. Any questions on that one? All right. Okay, so quick reminder, because it's really easy to make this mistake. I remember making it myself, so I want to make sure you don't make the same mistake I did. Okay. Log base b of m over n does not equal log base b of m over log base b of n. Looks like it should, but it doesn't. That's why it's a really easy mistake to make. Okay, and the same with if you were adding or subtracting. Log base b of m plus n does not equal log base b of m plus log base b of n. Again, it looks like it should work, it just doesn't. Okay, remember, this is our, if we actually ran this in reverse, that would be our product rule, and this in reverse, that would be our quotient rule, so they're completely different. Like I said, those are really, 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 really easy mistakes to make. And I made them repeatedly as a student, so. All right, any questions on this one? All right. Okay, so all those examples, we kind of got one logarithmic term and expanded it. So now we're going to do that in reverse. We're going to get multiple terms and create just one logarithmic term from that. Okay, so let's say, for example, no, not even. Actually, let's write the properties down pretty quick. Okay, so remember, log base b of m plus log base b of n equals log base b of m times n. That's just the product property flipped. Remember, log base b of m minus log base b of n is equal to log base b of m divided by n. And remember, that's just the quotient property flipped around. Okay. And also remember, kind of separate those. P times log base b of m is equal to log base b of m to the power of p. Again, just the power property flipped around. Okay, so you know whenever you see the plus sign, it's going to be product. Whenever you see the minus sign, it's going to be quotient. And whenever you have a constant or coefficient, you're just going to bring that up and make it into an exponent. Okay, so let's say we have, for example, I want to write the expression as a single logarithm. Okay, so if we have 16 log base 8 of x plus 1/3 log base 8 of y. Okay, so we want to write that as just one solid term. Okay, so the first thing I look at is the fact that whether it has a coefficient or not, because I know already that those coefficients are just going to be made exponents. Okay, so the first thing I look at is the power rule. Since you have coefficients, I have to write exponents anyway. Since you have coefficients, use the power property first. I mean, you don't have to use it first, but that's usually where I start. Okay, so that means that 16 become x to the 16th. So we have log base 8 of x to the 16th plus log base 8 of y to the 1/3. Okay, so all we did was apply the power property in reverse. Okay, so the next thing you want to look at is the fact that here you have a plus sign. So whenever you see a plus sign, that means product property. Okay, so that means you're just going to multiply those together. Okay, so that means you have log base 8 of x to the 16th times y to the 1/3. Okay, or you can rewrite it as log base 8 of x to the 16th times the cube root of y. Okay, so if the homework doesn't take one, it should take the other. But both are correct. All right, any questions on that one? All right, I'll leave that one up for a few seconds. All right. So let's say, for example, if we wanted to write the expression as one logarithm. Okay, so let's say if we have 1/2 log base b of x minus 2 minus log base b of y plus 3 log base b of z. Okay. So again, first thing I do is look at whether or not it has a coefficient. So if it does, I usually do the power rule first just to get rid of it. So get rid of any coefficients. Using the power property. Or power rule, whichever term you like best. Okay, so that means that 1/2 is going to go up here. So it's log base b. Remember, that's x minus 2 to the 1/2. So it's the 1/2 to the whole thing. Now this one, if you wanted to, you can make that y to the -1, but you don't have to because later on we're going to use the quotient property. So you can actually leave that as minus if you want to. So log base b of y plus, bring that 3 up to the top, log base b of z to the 3rd. All right. So now you're going to start looking at your signs. So here you see a minus sign. Which means quotient rule. Okay, so that means these two just become a quotient. So you have log base b of x minus 2 to the 1/2 power divided by y plus log base b of z to the third. So can't forget about the last one. Okay. Any questions on that step? All right. Okay. So now whenever you see a plus sign, that means product rule. Okay. So you just multiply those two together. Okay. So log base b of x minus 2 to the 1/2 power times z to the third over y. Or if you wanted to, you could rewrite it as log base b of the square root of x minus 2 times z to the third over y. And that's why it really didn't matter if you decided to make that y to the negative 1, because if you made it plus y to the negative 1, it would have been y to the negative 1 up here, and which would have just brought it down. So that's why whether you raised it to negative 1 or not, it would have still worked out. Yes? Oh yeah, you can do either one first. So if you wanted to start with those two, you would have had the product of log base b of y times z to the third, and then you would have still had the quotient rule here, which would have just made that log base b of y times z to, well, square root of x minus 2 divided by log base b of y times z to the third. Hold on, let me check. Oh, that's right, you do have to go left to right. Forgot about that. Sorry I didn't mention that. That's usually one of the first things I mention. To simplify. So it's kind of like the old, if you're doing the PEMDAS, you have to do the multiplication and division, you have to do it from left to right. Pretty much the same thing. All right, so any questions on that one? All right. I'm still writing. Okay, so now we're going to use the change of base formula. Okay. So that just says that log base b of x can actually be equal to log base a of x divided by log base a, oh, log base a of b. Sorry about that. Make that a little bit smaller. Okay. Which means that the reason this is helpful is because most calculators can only, just basic calculators, can only get the logarithm of base 2 or 10. So if you have any base other than that, most calculators can't help you. But you can actually convert it to one that your calculator can solve using change of base. So for example, oh, let me see, we didn't get to naturals yet, so I'll leave that there. Okay, so for example, let's say if you have log base 3 of 5. And your calculator only has base 2 or base 10, so you can't solve this one. You can convert it into, write that a little bit smaller. Log base 2 of 5 over log base 2 of 3. Or if you wanted to, log base 10 of 5 over log base 10 of 3. Okay, so either one of those would give you the same answer. All right, so any questions on that one? Okay. So let's say, for example, again, if you had log base 4 of 7, you could easily make that, like I said, log base 2 of 7 over log base 2 of 4. Or log base 10 of 7 over log base 2 of 4. All right. Okay. Okay, so here we're actually going to graph. I'm going to zoom out so you can see all of these. This is f of x equals log base 7 of x. Zoom out some. Can't zoom out. It's far out already. Okay, yep, got all 4 in there. Okay, so you're going to have some. We're going to ask you to see which one of these represents the graph of a log function. Okay, and getting the graph of a log function really is the same thing that we've been doing the whole time. So let's say if we have, make sure I'm not right above it, f of x equals log base 7 of x. Okay, we can just write that as y equals log base 7 of x, which is 7 to the power of y equals x. Okay. Now for this one, they kind of give you x and y values. Here you have x equals 1 and x equals 7. Okay, so you can pretty much pick those. So for x equals, well, for this one, x is equal to 0. Let's say x equals 0. Okay, so if x is equal to 0, 7 to the power of y equals 0. Okay, you really don't have anything to the power of y that would make that equal 0, so you know automatically that that's not going to equal, well, your x is equal to 1. So you know if your x is equal to 0, your y is not going to equal to 1. So you know that's not the graph there. Okay. Here, when x is equal to 0, you pretty much don't have an option. So you know no x equals 0 will give you a graph. Okay. So let's say when x is equal to 1.